Today, we're delving into a topic that's becoming more and more essential in modern industry: compressed gas filtration. Now, whether it's hydrogen for energy, clean air for equipment, or industrial gases for production, our world runs on compression. But did you know that those compressed gases can also be extremely vulnerable to contamination? At Schroeder Industries, we're not just aware of this, we are leading the charge in protecting gas systems with cutting edge filtration. Compressed gas systems face very real challenges: smaller molecules, intense pressure, and the risk of tiny, even microscopic contaminants making their way in. When that happens, the consequences can be severe: damaged machinery, compromised product quality, and even safety concerns. That's why we apply the same high standards to gas filtration as we do to liquid power applications. Now, today we met up with product manager Justin Keck to learn more about this amazing process.
Hi, my name is Justin Keck, and I am a product manager for the Fuels Division. I specifically serve the onboard and CNG market, whether that's helping distributors, sales reps, and customer-focused applications. So within a compressed natural gas application, there are multiple sources of contamination that can occur. Within a virtual gas pipeline, we have coming from the sour gas being processed to the gas dryers, gas aftercoolers, the compressors themselves, all the way down to the storage tanks and dispensing to point of use. We have loads of contamination that can occur at each individual stage. Some of those are, scaling and rust that come from corrosion of the actual pipeline itself or in the storage tank itself. You also have your compressor regulators and valves being damaged due to debris on the actual compressors themselves. You have hydrates that form at very high temperature and low pressures that can also cause issues downstream within the virtual pipeline, or actual clogging of the nozzles and orifices within the onboard system of the high pressure common rail as well. So when we talk about virtual pipeline, we are really referencing the entire process from the gas being drilled out of the ground itself and being processed through the making the sour gas actually feasible to be used on your onboard systems, but everything that's in between, from the processing all the way down to point of use, which are all of the stages of the contamination that we mentioned. So when we're talking about the compressed air applications, we have roughly the same types of contaminants that will occur on the CNG side, but our filters are able to be used in shop air or industrial air applications as well. So you still have your compressor that's going to be releasing water and oil aerosols downstream into your system or your point of use application, whether it's onboard for CNG, or if we're talking about CNC shops or paint air booths as well. A lot of those water and oil aerosols that come from the compressor get downstream. They can clog your hoses and lines, and filtration is required at all points of use, whether that's after the compressor or right before it's actually being used in the application itself. So for CNC, we have the actual pneumatic systems that require filtration prior to them being used, or that water and oil aerosols can actually cause contaminant or cause harm to the actual system, and leads to hundreds of thousands of dollars of replacing your components itself. On a paint air booth application, those fisheye blemishes that occur on unfinished paint goods, that's usually due to contaminants that got downstream and particulates actually clogging the nozzle, leading to the fisheye blemishes. So some of the challenges in comparing gas filtration, specifically CNG, to diesel fuel filtration, one is the particulate size is completely different. Within a diesel application, you can have a range between 2 to 30 microns given at any point within the system. And a compressed natural gas side, we are dealing with submicron particles down to 0.01 microns up to 1 micron in size. So very, very finite molecules that can get downstream and ruin your high pressure common rail system on an onboard application. So within a phase change, Phase changes occur at different points of the system, as we talked about, where the contaminants occur at different processes. So after the after dryers, or the after coolers, the dispensing units, the compressors, all these create different phase changes within the system itself, creating from oil and gas vapors to aerosols due to pressure changes and temperature changes across the system. This creates a harder point to try to pinpoint where the filters are to be located and how to actually remove these water and oil aerosols. So finding the key point of filtration and the point of use, so where that actually has to lay within a system, is a little bit harder than it comes to with diesel fuel. Diesel fuel, you're just trying to remove the water out of the actual fuel itself to keep the fuel dry and clean for point of use, in compared to compressed natural gas, where you have to have filtration at multiple different points within a single system, even at the bulk fuel storage and to point of use. So our filter housings are made up of cast iron heads and bowls, and sometimes machined blocks as well. This is due to the nature of where gas systems are seeing up to 5,000 psi at multiple different stages in a tire system, whereas in a diesel fuel application, the pipeline itself isn't seeing much more than, let's say, maybe 200 to 500 psi. So I'd say making key characteristic changes to the actual housing itself matter greatly in a system like this, where you're seeing constant pressure up to 5,000 psi, specifically at point of use. So within our compressed gas filter product offerings, we have simplified them to meet all your application needs, whether you're looking for onboard fuel filtration with our CGF 1.5, upstream filtration with our CGF 8, or even point of use dispensing applications with our CGF 50. All of these filter media actually use our same advanced media technology, which both have high particulate and water removal efficiencies, and very, very low micron rating filters. We even have a turnkey solution ready for point of use filtration. It comes with multiple different mounts if you're looking for a column mount, caisson mount, or even a K-rail or Jersey barrier mount style panel.
So, what's your application? If you're working with compressed gases of any kind, we're here to help. Our experts at Schroeder Industries can guide you to the perfect solution for your filtration needs, no matter the scale or environment. Whether you're in aerospace, automotive, or energy, clean gas starts here.